So, uh, let us start. Uh, Hope more people will join soon. Hello everyone. Welcome to our webinar, which is called Before the Breach, Audit Methodology and Continuous Blockchain Security. We are glad to proceed our series of webinars from Apriorit. I believe some of you know our company have more than 2 decades of expertise in development, specifically in delivery of cybersecurity solutions. And there is no need to stress how important cybersecurity is today. The world, unfortunately, becoming increasingly turbulent and less safe. As far as we rely more and more on blockchain finance, identity, and communication, we decided to talk about how to avoid critical mistakes before a project goes live and it becomes a disaster, basically. About the security audits. Okay, let us start. And meantime, while we are waiting, let's review our plans today. Our lecture will be about 30 minutes. We'll upload it to our social media, so don't worry, you won't miss anything at any case. After the presentation, we'll have a Q&A session, so feel free to ask your questions in the chat during lecture. They are really appreciated. We'll answer on everything during Q&A. And basically, let me go through the agenda. I believe you should see the presentation. Okay, so today we'll talk about the security of blockchain, real-world attack examples, what is blockchain security audit itself, about its life cycles, methodologies like threat modeling, static analysis, dynamic analysis, business logic, and gas optimization, and much more. Definitely about the cost of an audit. And the last one will be from one-time audit to continuous security. By the way, I'm Alex, a project manager at Apriorit. And I'm managing the projects regarding the blockchain audits, cybersecurity, and so on. And here we will have Serhii Rubets. Please meet him. He's our software designer and one of our key experts in blockchain field. All right, I guess enough of me talking for now before this turns into one-person podcast. Serhii, the microphone is yours.
Thanks, Alex. Nice to meet you all. So let's begin. And before we start talking about the risks in the blockchain, let's talk about the strengths of the blockchain, what makes it secure. So the blockchain applications are built based on several aspects. Decentralization allows us to remove a single point of failure from the system by distributing data across multiple nodes and requiring those nodes to reach a consensus. Those nodes operate in a transparent way. We can see a history of transaction, and we know what the code should be executed. So by providing the same inputs, we can also verify the results. And the last aspect is immutability. The confirmed operation could not be reverted, and this aspect is protected by decentralization. Apart from strengths, there are also common attack vectors. On blockchain level, the malicious actor usually attacks infrastructure, such as a network layer or nodes. Then goes private keys, usually by phishing attacks, attacker tries to steal them. And the manipulation of consensus mechanism, it usually revolves around exploiting some weaknesses in protocol. On smart contract level, the most common issues are logic errors, like reentrancy or something application-specific. Communication channel, it involves exploiting interaction between the system and external data providers, such as Oracle. And the algorithm flaws, like weak cryptography or randomness. Let's give you an example of what we mean by providing some real-world attacks. For example, with BonkDAO, it's a landing protocol on Polygon that was exploited for $120 million, and it was done by exploiting price changes, which allowed the attacker to borrow more than the collateral should allow.
That's a pretty costly example of what can happen when a protocol blindly trusts price inputs without any safeguards, I believe. And the scary part is here is that logic was technically working as intended. It just didn't include a validation step, as far as I remember.
Yeah, you're correct, Alex. So validation of what we expect should also be present in the contracts. Another example is the calendar attack. This is a layer 2 money market protocol on Starknet. And due to rounding error, it caused 10 million loss. Interesting fact about this issue is that this error originates from the library called SafeMath. So you will expect that SafeMath always gives you a safe result, but you also need to know how to properly use this library to get your safe result. What is a blockchain security audit? At its core, an audit is a deep and methodological process where we analyze a project, which can be smart contracts, underlying blockchain protocol, or supporting infrastructure like nodes, API, or even some other off-chain component that interacts with the system. It is important to perform security audit by independent experts. You need a third party to get an objective and unbiased assessment. The goals of an audit go beyond just finding bugs. It also includes understanding of impact and how to remediate the issue. Audit can also provide you with recommendations that are not security issues, such as best practices. And finally, the audit allows you to build trust with community by providing an assurance of security.
Oh, that remind me of one thing. Speaking of the examples, during one of our audits, we encountered a smart contract that had an entry point, allowing the admin to transfer access token, as far as I remember. Now that in itself might not raise red flags, since admins often have some level of control for maintenance. But here's the issue. The same contract also implemented staking functionality where users could deposit token and earn rewards. Due to the way the logic was structured, the function didn't properly distinguish between excess tokens and staked user funds. As a result, the admin had technical access to withdraw not only leftover tokens but also the staked tokens, effectively gaining full custody over user deposits. This wasn't an intentional backdoor, but it created privilege escalation scenario where an admin could bypass staking logic and retrieve funds directly. That's exactly the kind of risk that may not be obvious from business logic alone, but becomes clear during a proper security audit. Right, Serhii?
Yes, that's a good example of where the trust with users needs to be built. So not only your project should be secured from attacks from external users, but also users should be assured that you could not exploit the platform in any way, and their funds will be secure in your project. Now let's talk about the life cycle of audit. We can split it into several steps. First come the definitions of the scope and provisioning of all required resources, such as code base, documentation, etc. At this step, it is important to have a feature complete code and final commit. Introducing new features in the middle of audit changes all the context, and it will require to start this life cycle again from the beginning. The second step includes getting acquainted with the code and understanding potential risk. With this, we can proceed to the next step, which is project analysis, where we actually analyze what's happening and what issue we have. And as a result, we will provide a draft report. On this stage, there will be a discussion between project team and audit team to validate the findings and come up with a remediation plan. Once the project team completes all the fixes, there will be a next step which involves the verification of those fixes, and basically it's a re-audit of new changes. Once the re-audit is done, we go to the final step. It's a report that provides with a final assessment of the security and verify that all the issues were fixed if any were found. If we talk about audit methodology, I think that it is important to give you an example of the most common request that we get. It's the audit of smart contracts. But actually, this methodology can be applied to any other type of the project, not only blockchain, excluding some of the steps that are specific for blockchain. Our structure can be easily mapped to any other type of project. We begin the audit with the definition of potential risk. To do so, we need to identify assets. It's what needs to be protected in your system, actors, entities that can interact with the platform. And by analyzing how those actors and assets interact, we can determine potential attack vectors. And on the later stages of audit, the threat model will help us to focus on complex scenarios and review the completeness of the audit.
Yeah, and by the way, it's always surprising how often the biggest issues don't come from one contract doing something wrong, but from two contracts doing exactly what they were told, just not together. Yeah. So.
Yeah, that's happens oftenly, and that's what we trying to determine, trying to build all these threat scenarios and verify them. And after we come up with the threats of the platform, we go to the analysis, and we're starting with automatic tools. Those tools can go over the code quickly and identify known vulnerability patterns. For example, linters or built-in compilers in some cases can provide with basic information about the code, whether everything follows standards or everything builds. It's important to start the audit from this step. Static analyzers such as Slicer or Mithril, they allow us to search the code for known issues. And it can also be done using AI models that were trained to search such patterns. This step is called the static analysis because tools analyze the code without executing it. If analysis includes execution, it's called dynamic. This step involves writing tests and custom scripts, and we attempt to exploit the platform. Some tests can also be executed with a huge array of random data, in which case we can find some unexpected status of the platform and some unexpected behavior. Usually, dynamic analysis is done in the combination with the next step, the manual review. This review should be performed by an experienced auditor that knows the required technology, knows business logic of the project, and knowledgeable of attack patterns. By diving in complex interaction, access controls, and state management, we can uncover subtle issues that may lead to critical vulnerabilities.
By the way, let me add one more example here from a recent audit that fits under business logic and manual review. We were assessing a staking platform composed of multiple smart contracts. After user deposits tokens, they received staking tokens and became eligible for reward based on their stake. However, the system calculated available rewards for each epoch without actually referencing the current staking token balance. This created a critical flaw. A malicious user could deposit tokens, receive the stake tokens, immediately transfer them to another wallet, and then withdraw the deposit, while still being eligible for rewards in the original account. So even though their balance dropped to zero, they were still rewarded, effectively draining the reward pool. It's a good example of how everything can look fine and the code level, but the business logic can still open and unintended attack vectors, as well as and it might be found only on the comprehensive manual review stage.
Yeah, in this particular scenario, it involved four contracts interaction between each other, reading data from each other, and in the end resulting in potential rewards loss.
Yeah.
So let's go to the next step, business logic review. It is also important to not only focus on what we have in the code, but what the code should do. That functionality should match what we have in documentation. All features should be fully and correctly implemented, and also there should not be any undocumented functionality, like remnants of old code or side effects of chosen approaches. It often leads to unexpected bugs in the system and can provide with unintentional functionality that is not covered by your expectation. The last point in our methodology includes several steps which are not directly security risks, but can improve the quality of the code. Gas optimization helps to reduce the cost of operations, and it provides the user with a better experience. Code quality assessments helps with maintainability. It can also include a high-level recommendation about project architecture. And lastly, the analysis of unit test coverage can help to maintain security when working on the next version. It is important to verify the correctness of the tests, because it may happen that the test passes, but the actual test verifies not what the code should do. And let's speak about the cost. The main aspect that impacts the duration of the audit is the size of the code base. But it's not only the number of lines to review, it's also about the complexity of the code. If the project introduces a new algorithm that the auditor needs to learn, it means the auditor needs to understand all the theory behind this algorithm and spend time outside of your code and with your documentation to fully be able to understand all the scenarios that may happen. Complete documentation helps with this. Finally, if there is any missing feature, it negatively impacts the audit duration. It requires additional work from the auditor because we need to build assumption of how the platform works, and all those assumptions need to be properly documented by the audit team, so the security assessment will be still correct, and in the end the project team will know on which assumption the auditor was working. The security concerns of the project doesn't end with audit. It is important to implement continuous security. Introduction of a new feature requires to re-audit to not impact the security of your current project. Bug bounty helps to leverage global security community. while audit is an in-depth analysis that is done by one person or small team. Bug bounty often attracts hundreds of people, but as a trade-off, they provide only a shallow review or focus on one specific component. For an active project, monitoring systems helps to respond to an incident upon noticing suspicious activity, though the steps require proper planning. Having a community that engage in the project can help with an early response to the issue, and it actually happens multiple times when people on Twitter or in Discord point to suspicious activity, and the project team responds quickly and starts the losses. And also remember that it is also important to follow security practices in your team. Management of the keys, management of environments, and awareness of phishing attacks always helps to keep your project secure. That's all.
Okay, so thank you, Serhii. I believe we can now talk a bit more with our participants. So feel free to ask any questions. I will go through the chat. Okay, so we have a comment from William from Chicago. Just a comment regarding the open source tool for the audits, I believe for static analysis. We'll go through it and check after the. Okay, any more questions? Serhii, everyone is basically satisfied by your story. So, see no questions so far, only pluses.
You can always ask the questions in commenters. I'll review it.
Sorry?
You can always ask your question in the comments, and we will review it and answer.
Yes, by the way, you can always ask your question in any of our social media, and we'll go there and answer it as well. Okay, Serhii, I believe it was great. So thank you all for joining us. Thank you, Serhii, for the webinar. And please join us through our social media. And looking forward for your attention. See you on the next webinars and have a great day. Bye-bye.